All right, everyone. Hello and welcome to the webinar. My name is Josh McDaniel and I work with the Wild and Fire Lessons Learned Center. I think you're going to find the presentation today very interesting and also very useful. We're going to be covering the MTBS, or the Monitoring Trends in Burn Severity project, MTBS. It's a multi-year interagency project designed to map the location, extent, and associated burn severity of large fires occurring all over the United States from 1984 to the present. Before I introduce the speakers, though, I want to make a few announcements. First, just point out that the webinar, this is part of a webinar series. We've been doing webinars about bi-weekly at this point, and that will continue hopefully into the fall. And this is jointly sponsored by the Joint Fire Science Program, the International Association of Wild and Fire, and the Wild and Fire Lessons Learned Center. I've put up some links on the site to invite you to check out the websites of all three of those organizations, and they are generating some really great fire science products. And not to encourage you to wander off while during the presentation. We want you right here with your complete attention, but after the webinar series is over, please feel free to go check those out. Also, I wanted to tell you about some upcoming webinars. The next webinar is sort of the second part to this webinar that we're having today. So today is going to be a project overview, sort of describing the ins and outs of the MTBS project. And then next week, Eric Gadula of Grand Canyon National Park is going to show how the park has been using the burn severity information in their fire and resource management programs. In July, on July 12th, Alan Ager is going to present another webinar covering a new tool for fuel treatment planning, the Landscape Treatment Designer, and that'll be on July 12th. Okay, you can register for both of those webinars on the Advances in Fire Practice website. The link is right there. Tough link to type in, but you can Google Advances in Fire Practice and it should come up, or you can navigate to it through the Wild and Fire Lessons Learned Center website. Okay, real quick, I want to do a couple polls to see who our audience is a little bit. Okay, so the first question is, what best describes your connection to wildland fire? And you can choose more than one answer here. So I know sometimes people wear a lot of hats, and so whichever ones seem to cover your job the best, go ahead and pick those. Okay, most everybody's voted now, so I'll close it and then put that up. So 55% firefighter, fire managers, 35% land managers, 11% administrators, 22% outreach and education, and 36% researchers. So a little higher of a researcher participation today. Okay, and then next question is sort of who you work for. Alright, most everybody's voted on that one too. Okay, so I'll put that up. So, the high percentage from the federal land management agencies, next largest state and local, 13% education research institutions. Okay, alright, so thank you guys for that. That gives us a little idea of who our audience is and helps us plan presentations. Now on to today's webinar. I'll introduce the speakers in a second, but I just want to let you know how the questions work. So throughout the presentations, you can type in questions at any time, and we won't address them until after the presentations. We'll have a Q&A session. So depending on what sort of platform you're on, you either have a box that says questions or chat, and you can type questions in there, and then we get them, and then we'll read them out at the end of the presentations, and the presenters will respond to them. So I encourage you to get those in early. To get to the top of the list, you're guaranteed of getting, or more guaranteed of getting it answered than if you wait till the end, because then the list gets pretty long. Also, the webinar is being recorded and archived, and the link to the recording will be on the Advances in Fire Practice webpage as well, and I'll try to put that link up towards the end. Well, there it is on the screen right now, but I'll put it up at the end as well, so you can pass that link on to anyone you think might be interested. And okay, so that should take care of housekeeping. there's two presenters today, and one, Josh Picot, is the first person I'm going to introduce, but Josh actually, his internet connection is down, and so he is calling in for the webinar today, and Jennifer is going to be handling the PowerPoint presentation for him, so we've been patching it together here at the last minute, but it seems to be working okay. But Josh Picot joined the science contractor staff at the USGS Earth Resources Observation and Science Center in January of 2011 after spending 4.5 years at the Tall Timbers Biological Station in Tallahassee, Florida, where he supported the National Park Service and other federal cooperators in the use of remote sensing imagery to map fire severity. At EROS, Josh works with the Monitoring Trends and Burn Severity team to map severity of burns across the U.S., but concentrating on the difficult task of mapping fires in the southeastern U.S. Jennifer Lecker is going to be speaking after Josh, and Jennifer is a remote sensing specialist with the Forest Service Remote Sensing Applications Center in Salt Lake City. She's originally from St. Petersburg, Florida, and educated at the University of New Mexico. She's lived and worked and played in Salt Lake for the past 5 years. At RSAC, she's a team member of the Rapid Disturbance Assessment Services Program, with post-fire mapping being her specialty. Okay, so with that, I will turn it over to Josh.
Okay, can you guys hear me okay, Josh?
Yeah, if you turn your volume up a little bit, maybe.
Okay, no problem. Is that better?
Yep, that sounds better.
Okay, gotcha. Okay, so Jen's ready to start. We can definitely start the presentation. Again, I'm sorry for any of the problems. We've just been having a few technical difficulties at EROS today, and yeah, we're working through them, so that, it's going pretty well.
So I have your PowerPoint on the screen, just showing the intro slide. So I will move to slide 2.
Okay. So today I'll specifically be talking about Monitoring Trends and Burn Severity project, and I'll specifically address the project background, mapping methods, geospatial data products, production status, challenges and limitations, and finally the future direction of MTBS. And so just to give you a bit of a background about MTBS, MTBS was originated in 2005 to assess all large fires that occur in the U.S. regardless of administrative ownership. So sponsorship has been provided by the Wildland Fire Leadership Council, or WFLC, to map all fires since 1984 that are larger than 1,000 acres in the western and 500 acres in the eastern U.S. These acreage breakpoints were originally put into place at the beginning of the project to limit the amount of fires that we mapped, to basically reduce our budget, reduce the amount of resources spent on mapping smaller fires that don't contribute as much to the overall fire acreage within the U.S. And so during the 1984-2010 time period, and I would like to state that the reason we started in 1984 is because that's when Landsat 5 was put up into orbit, and that's when we started being able to map fires. And so that's kind of our initial date. And so all the fires we've mapped so far, which would be 1984 to 2010, have occurred within the continental United States, Alaska, Hawaii, and now we're starting to map Puerto Rico as well. It's not that many fires in Puerto Rico, but those will get added to the archive eventually. And so MTBS will continue to map fires in the future, and right now we're actually working on the 2011 fires. As I mentioned before, MTBS uses Landsat imagery to provide an estimate of the burn severity of fires. Next.
Okay.
In this context, MTBS defines burn severity as a vegetation change. So any change that can be seen in the landscape, damage to vegetation, that's what we're talking about. And this is because vegetative change is readily discernible on Landsat imagery. For example, if you look at the slide on the screen right now, if you look at the first image on the left, at the top image, that's a pre-fire scene. You can see that there's not a lot of landscape change. It basically shows green and pink with their soil exposure or some sort of rock exposure. If you look at the image right below it, the post-fire image, you can actually see a fire scar in kind of a deeper pink color. So you can actually see, again, the fire scar just looking at raw Landsat imagery. What we actually do is we difference the near infrared with a short wavelength infrared bands and divide by the sum of those two bands to produce a normalized burn ratio image. So if you look at the image next to the Landsat image, you'll see the normalized burn ratio image. The top image is, again, the pre-fire image. You can't really see any fire scars. Any sort of change when you're looking at MBR images should show up as darker colors in this example. If you look at the post-fire scene, you'll see the fire scar shows it dark. The reason we use the normalized burn ratio is because vegetation and soil damage is readily apparent within the post-fire image, while unless there's some sort of other change from another fire or something else, no change shows in the pre-fire image. And so you can see, again, that there are differences in the pre- and post-fire image. If you then difference the MBR images, so you basically take the values from the pre-fire image and subtract the values from the post-fire image, you get the difference normalized burn ratio image, or DMBR image. And the DMBR image shows the actual amount of change that occurred between the pre-fire and post-fire image. Now, in this case, you can see the fire outlined well. You can see that there's a lot of change outlined in white, the changes in white. And there's actually some highlights in about the right-hand corner of the DMBR image. And what that is that's some other change or another fire. So it basically shows, the DMBR image will show any sort of change in the landscape. So you basically have to know approximately where your fire is so you can define where the actual fire occurred to. Excuse me. MTBS produces thresholded different normalized burn ratio images. And when I say thresholded, that's the last image. You can see that it's been thresholded to unburned, which is dark green, mint green, which shows low severity, yellow, which shows moderate burn severity, and red, which shows high burn severity. And these maps are produced by visually determining the burn, excuse me, the low, moderate, and high severity thresholds. And so these are basically manually produced photo interpretation that are somewhat subjective. So we have analysts that go and map these images. So that, again, it's just a human interpretation of burn severity. However, we should say at this point that over 15,000 images have been interpreted, and so analysis of these data offer the possibility to determine default thresholds for regional and vegetation types. So even though it is somewhat subjective, we've done it so many times that the MTBS project has a feeling for what these breakpoints are. And again, they've been looked at with ground control points for some fires, so we have a pretty good idea where most of these thresholds exist. Next slide, please.
Okay.
So MTBS produces multiple geospatial data products. Really the first couple we produce are, as I mentioned before, the thematic and continuous 30-meter DMBR raster data set. So that's one data product that's produced for each fire. The DMBR image, the raw image, was used to actually hand draw a perimeter around the fire scar. And right now we're working on scripts to kind of do some of this, to automate some of the fire permitting a little bit more, but that hasn't been totally developed, and there's still more work to be done. And if we did, and if the MTBS project does create automated burn perimeters, then those will also be visually assessed to make sure they're correct. So we won't just produce a product without looking at it and making sure that it's accurate. Additional mapping products, and I should mention too that all these products, Jen's going to go through, talk to you about those after this. I'm just going to really discuss them briefly. The additional products we produce are Primal maps and Google Earth KMZs. And finally, we produce metadata that describes all the data that's distributed on the MTBS website, which is mtbs.gov. Okay, Jen, you can switch.
Okay.
Okay. So currently, this is just the production map of the entire U.S., where you can see that everything is outlined in green except Puerto Rico. The reason being is because all of the 1942 through 2010 for Alaska, Hawaii, and the continental U.S. have been completed, and they've been released on monitoring and burn severity.gov, so mtbs.gov. Puerto Rico should be up in the, hopefully the next, by the beginning of the fall, beginning to end of the fall. So Those will be coming up pretty soon too. So production is going to continue in the future, 2011 and beyond. However, I should mention that because Landsat 5 has now failed, this is really going to impact the project. And so from now on, actually at the end of 2011 is when, in November of 2011 is when Landsat 5 failed. From then on, we'll be using Landsat 7 data until Landsat 8 data is available, which won't be until December December this year, hopefully. We'll see. And so Landsat 7 imagery has scan line problems, and so our data won't be as clean as it used to be, but we'll keep, mapping fires until we get a new viable satellite. So currently, on an annual basis, we map all fires within 12 to 18 months post-fire. And right now, RSAC is mapping all the yearly fires. And then EROS is currently mapping all the 1984 to 2010 fires that may have been undocumented or missing due to image constraints. So at one point we were buying, MTBS project was buying imagery, all the data is free, so now we can go back and look at the archive to make sure that we have the best imagery for each fire and that everything is mapped appropriately. So that's kind of what EROS is doing. We're going through and looking at our fire list to make sure we've mapped everything possible. Next slide, please.
Okay.
So there are definitely challenges and limitations to the MTBS project. The first one is just the fire location. That the MTBS fire data is only as complete as the fire records are accurate. If the geospatial location is significantly off and the fire may not be mapped, that definitely happens sometimes. Our data records vary widely between our different data sources. The next challenge is that, we don't know if there's going to be a data gap. Right now, Landsat 7 is the sensor of choice for MTBS. And we're hoping it continues at least until December 2012 when Landsat 8 will hopefully be up. Another problem is that satellites, can't detect fire disturbances under dense tree canopies. So in some areas in the U.S., if you have a low severity fire underneath a dense canopy, you're just not going to be able to see the ground effects. So sensor characteristics can really be limiting when we're mapping fires. And so if you look at a threshold image, if the canopy wasn't affected at all, then some areas may show up as unburned that were actually burned. Another problem is that sometimes difference normalized burn ratio isn't the best approach in all ecological settings. For example, if you're in a wetland and if you do a DMBR image and there's water level changes, those water level changes will show up as severity. And so in those cases, MTBS maps using a normalized burn ratio image and doesn't difference between the two. Thresholding of the difference normalized burn ratio is always visual and therefore it can be subjective. So there are differences between fires because of differences that exist between analysts. However, again, we've talked to different regional experts and we've ground truth some of the data to make sure that we utilize regional threshold models and calibrate that have been calibrated using plot data. And we just try to use the best breakpoints possible that are at least known. And excuse me, the assessment and timing or analysis of can be affected by several different factors, including time since fire, vegetation regrowth, availability of cloud tree imagery, and subsequent land management activities or disturbances. So basically, any sort of disturbance or any sort of change, be it spectral or actual landscape change, is going to show up on the screen, show up on the imagery. So that can always be limiting. So if you have logging after a fire, that will show up as a disturbance, and that can impact how the fire is thresholded. And finally, small fires. Small fires may equate to hundreds of thousands of fires and about 5 million acres a year burn that are small fires. And when I say small fires, I'm talking about less than 450 acres in the east and less than 950 acres in the west. So in the past, there were problems with getting all these additional fires, including image cost, manual selection, et cetera. And so we believe that MTBS has captured about 95% of the burned area from 5% of known fire occurrences. However, there's so much more data about smaller fires, and because Landsat Archive is now free, we may be able to develop some sort of automated process to start efficiently data mining for these smaller fires. Next slide, please.
Okay.
And so kind of the future direction of MTBS is that the kind of overall concept is that a fire event, or basically any other disturbance, can occur at any time of location at a certain time. So if you know that disturbances, location, and date, and any additional information from agency records, from satellite fire detections, you can actually use that information to drive an automated process to identify candidate Landsat scenes that will show the landscape prior to and after the event. And so in the future, MTBS may move towards a more automated process that will determine all the pre- and post-fire images so that the user can then determine the best pre-fire and post-fire scene pairs. Unfortunately, I can't go through my demo right now, but basically what it would show, and this is via Google Earth, is that you can have everything load up to Google Earth, and you can pick images very quickly. You can load up everything available and then make some changes. Make your selection. And MTBS has actually developed some packages to help us do this. And then you could, after you select scenes, you can then create DMBR images, water cloud, and shadow masks. And then either the mapping can be done by a user or automated. And then finally, there can be some subsequent post-processing steps to create threshold images. So that's just kind of hopefully one of the directions. A lot more of the really some of the time-consuming tasks MTBS does can be automated, so the analysts can focus on mapping as many fires as possible and creating the best data sets as possible. So I guess I'm hitting about my time limit. So next slide, Jen.
Okay.
So I don't know if you want to do questions now. If there's time, I can take questions. Otherwise, Jen Lacker will talk about accessing monitor gens and burn severity data.
Yeah, let's hold off on the questions till the end, I think.
Okay, sounds good.
Thank you, Josh. So I'm just going to show you guys a little bit of the features and functionalities of the MTBS website, which again is mtbs.gov, and accessing the data. A little bit of the basic navigation tools. I'll highlight a little bit on some of the project information and details where you can find that on the website, but mostly I'll try to focus on the data access and some of the different portals and search criteria to find specific fire data that you are interested in. So this is the home page for the website, and on the home page we just have a little bit of information on the project background, objectives, it's a collaborative project. But more importantly, on the left-hand side here, you'll see that there is a static navigation bar where this is present anywhere you are in the website. So this will be your primary mechanism for navigating within the website. So I'll just start from the top and review a few things along this menu here. So on the home page, at the bottom here, there's a link to our What's New page, or you can also access it in the toolbar here. And that just gives a good summary of anything that's going on in the project as far as data releases, or like just last week we found an anomaly in some of our reporting data, so we wanted to put a note up there for anybody that may have gone and downloaded some of the data. There's also information on trainings, modifications to some of the projects. So if you're needing some information or there's changes, this is a good place to look. On the background and partners, that's self-explanatory. One thing to note here on this page is that we do have a definition of burn severity. As many of you are probably aware, there's varying definitions out there of what burn severity or fire severity is, and so it's good information to know how this project defines that. On the Documents and References page, again, pretty self-explanatory, but there is the original project plan here that's downloadable, an overview, some of our presentations that we have online and posters for you to view, as well as the Scientific References page, which Josh talked about the normalized burn ratio and the difference normalized burn ratio severity indices that we use to do a lot of our mapping. And so there's lots of peer-reviewed journal articles, conference proceedings, and then also listed by discipline here, using those two indices for hydrological, questions, fuel treatment effectiveness, and different things. So there's just a wealth of information here for anybody that's interested in using NBR or DNBR in some of their work. The methods page, I'll let you all read about that. The product description page I do like to point out because I think it's just a good comprehensive overview of what we provide in each of our data bundles and national data sets. It's a good time to show you this sort of tabbed and accordion format that we use on the website sometimes on certain pages. So we have the individual fire level geospatial data tab here, and this just gives you an overview of each of the products that you'll find in the individual fire data bundles that you can download. So currently we have nearly 15,000 fires that are available throughout the U.S., and each of those will have these different products. So if you just click on these little accordions, it'll give you a little overview of what the product is. I do like to also point out that it has the file format, which is GeoTIFF for some of the products, and then also the file name. Because when you download an individual GIS bundle for a fire, this is basically what you're going to see. And you're going to unzip this or decompress the file, and it's just going to be a long list of files, and you're not going to know maybe what is what. So next to the file name here, you can see it's listed as the fire ID. This is the post-fire image, for example. Fire ID underscore post underscore reflectance image dot TIFF. So when you go and you unzip it, oh, there's my post-fire image. So you'll be able to associate a product in the file here to the website, or to the actual product in the data bundle. Same thing with the national geospatial data, and I'll show you once I get to the data access page what these products are. But again, it just gives you a little brief overview of some of the products for that we have available on a national scale. Mapping status, you've already seen this once. Applying MTBS data, I'm going to leave this for next week for Eric Gadula to talk about. But there are some documented uses here of different projects that are using MTBS data, and links to their websites or project pages that and how they're using the data in their specific projects. And then again, here's another tab with some accordions on how potentially these data can be used. Project reports, we are in the midst of, since we are wrapping up the baseline data set 1984 through 2010, we're in the midst of doing some pretty comprehensive analysis. So this page will be updated later this year with fire trends and data analysis from spanning that time period. So we will post those there. This is a little bit out of date. I'm going to skip data access for a minute, jump to tech transfer. Anytime we host trainings and workshops and things, we like to post the announcements as well as the training materials here. So you can click on any of these links and it'll have the PowerPoint presentations, the GIS data exercises, and all of the associated data that you'll need. So there is some good information here if you're interested in downloading those. It might be something good for you to look at. The glossary is always a good thing to know about. We throw around a lot of terms that maybe some of you aren't familiar with, and in your readings on the website and other places might help you pinpoint what we're talking about. Related websites is just that. The FAQ page is nice if you download some data or you're just scratching your head about something. This is a really good place to come. Again, it's in this tabbed and accordion format. For example, here's a geospatial data tab, and it has it's in question format. So if you're wanting to know what the thematic burn severity description classes are, you'll be able to find a lot of answers here. So please refer to that page. And then finally, there is a Contact Us page. This is a general mailbox here, mtbs@fs.fed.us. Feel free to email any questions that you have at all, or if you need technical support, you will be answered. And then also here is email and contact information for the two project leaders, Brad Quayle here at the Remote Sensing Application Center and Steve Howard at the AROS Data Center in Sioux Falls. So feel free to contact them as well. Okay, so for the data access, when you come to the data access page, you'll see just some information here at the top that last week, as of last week, I think that was last week, we uploaded a little more data, so that'll give you an idea of when the last data release was. You can get more information on that, which will just take you to the What's New page. And then also you can get new data, which will take you to this individual fire level geospatial data portal. But when you come to this page initially, you'll basically see three portals. The first one here is the data summary tools, and this is just an application where you can go in and do online analysis of any of the MTBS fire data that we have available. You can query it spatially, you can query it temporally, and I'll show you those tools in a minute. I'll finish up with that. But first, there's an individual fire level geospatial data portal for accessing user-selected fires. So if you're interested in a particular fire or a group of fires, this is where you would find that information. And then there's also the National Geospatial Data Portal as well for our national composite data sets. So I'll start out by showing you the individual fire level data portal. So you just click on the Get MTBS Data and then click on the Data Search and Distribution Tools. And in the query builder here, you'll notice that there's 8 different criteria that you can build a query. And you can use a single criteria here or any combination of them. So I'm just going to do a sample query. I'm going to choose, let's do May of 2002, May 1st through the end of July 2006. You can also do all years, and it'll give you all 15,000 fires. Also, you can choose release date, which is beneficial if you've come to the website before and you've downloaded a bunch of data. If you click here, you can choose the latest release. So if you haven't been here in a while and downloaded data, you can choose only the latest data release so that you don't have to download everything again. But I'm going to use my fire occurrence date range here. Spatially, you can choose by either states, geographic areas, or by lat long by entering your coordinates here. But I'm going to choose states, and you just simply choose the state that you're interested in. I'm going to choose Arizona and add it to my selected states box. I'll also do California, and I'm partial to New Mexico. And you can also limit your query by using a fire name as well. And we're well aware that fire names vary widely. So this is a smart search tool. I'm going to type in the word big, and it'll give you all of the fires that have the letters BIG in them. So you can choose that way as well, but I'm not going to limit it by name right now. Also by admin ownership. So just as an example, I'll choose BLM, Park Service, and Forest Service. You can choose a size threshold as well, or you can have a specific size, and then you choose either equal to, greater than, or less than, a little delimiter there, or you can choose a range between two fire sizes, between 5 and 10,000 acres is what you're interested or whatever. So I'm going to do greater than 10,000 acres, let's say. We also have a fire type option here, where if you are interested just in, say, prescribed fires, you have to deselect the all and then deselect wildfire and wildland fire use just to have prescribed fire highlighted here. But I'm going to do all. One important note here is that in our source data, a lot of times this designation, we're not given that information in the attributes. So if that information, if a fire is not specifically designated as a wildland fire, use fire, or prescribed fire, we tag it as a wildfire. That's the default. So that's kind of an important understanding. Also by assessment type, we did not discuss initial or extended assessment too much, but this is basically the time period in which the imagery was pulled to map a specific fire. Initial assessments are typically within 30 to 60 days post-fire, and an extended assessment is in the green-up period following the fire. Sometimes that's a year out, or sometimes a shorter time period. So you can stratify your query by that information as well, and then also by data version. Sometimes we post a fire to the website and then find out later that that we had some incorrect information and we need to remap it in some way, shape, or form, and so we will tag it as a revised fire and pull down the original fire data set. But you can stratify that in your query. So I've got everything here that I want in my query, and down at the bottom here it just sort of summarizes what I have with my time period, the spatial extent, ownership, size, and I'm going to submit it. And what I come up with is a total of 86 fires that meet that query. For each of the fires, you'll notice that there's a fire ID. It has the name. This is the results list. Fire type, your version, a revision code. If it is a revised fire, it'll tell you in this revision code key why we revised it, and then also the associated release date. And for each of the fires, each of these individual fires, we do produce a PDF map, which looks like this. This is the Viavesh fire of 2000 in New Mexico. And basically it's just an easy PDF that's pre-made that you can download. It shows the post-fire image and then also the associated burn severity with a little graphic here showing the severity stratified by acreage. A little locator map and a little bit of information on the assessment as far as the assessment type and the pre- and post-fire imagery that was used. You can download these products individually by either clicking a specific PDF icon here for a fire, or you can click on the radio button above that particular product and it'll download all 86 PDFs all at once by clicking the download all button. So you just choose your product and then click download all. Also, for each of these fires, either individually or as a group, you can download the KMZ file. If you were to click on this, you would and you have Google Earth installed, it would fly to your fire, and I've already got it open here because anytime I try to do this in a live demo, it fails, of course. So I have flown to the Viavesh fire. And if you click on the top layer here, it'll give you just a little summary of the particular fire and some of its attributes. In the embedded layer, if you click on that for each of these, you can turn off the legends and the logos here. Sometimes that's not desirable. And you can also, there's an option to view all of the data layers that we have available. So here is the pre-fire image, and this is in a Google Earth environment, so it's all dynamic. You can zoom in and out, you can spin around, anything that you want to do. Here is the post-fire image, your severity layer, as well as the fire perimeter here, and all of this is draped over the base imagery in Google Earth. There's also a transparency feature here where if you hit the transparency, you can change the opacity if it's going to let me do it. And it's not. But anyway, this is a transparency bar down here. So if that was working properly, that would be great. But it's not. So anyway, here is the KMZ files that are available for each of the fires. And again, you can download all 86 by just clicking the download all. And here are the GIS data bundles that have all of that information that I showed you that's available for each of the fires. Again, you can download all of them at once. So that is the how you create a search for either a specific fire or a group of fires, and you want to access any of these three products, the PDF, the KMZ, or the GIS data. I'm going to go back to the home page here for the data access and show you these national geospatial data composites that we put together after each data release as well. The national MTBS burned area boundaries data set is a nice one. It's a polygon shape file that you can pull in that has that you can download, and it has information on all 15,000 fires. It has some nice attribute features, including the fire name, ignition date, acres, etc. So you can get at a glance all of the fires that are included in this data set. Also, we have the fire occurrence data, which is a point shape file, and that one has a little more information on the mapping as far as the assessment type, the pre and post fire scenes that were used, the thresholds that we applied to create the severity classes. So that's an interesting and helpful one as well. And then also there's the National Burn Severity Mosaic. So if you're looking to get just the severity data for a specific area, either the continental U.S., Alaska, Hawaii, and Puerto Rico for a certain year, we have taken all of the severity data for that year and mosaicked it together for you, so you can just pull it in and use it without having to do any of the processing yourself. So you come here and you just choose the area that you're interested in and the particular year, and then download the data. And then finally, there is the data summary tool, which again is a customizable way to do some analysis online. So there's a total of 4 steps to use this tool. First off, there is your fire occurrence time period, and this is based on the fire ignition date. So what you want to do, there's 3 options here that you can choose. The first one is the date range search, which is simply just a search of fires from time 1 to time 2, and you'll get a single summation for the entire time period. The second type of search you can do is a linear search, which displays results from time 1 to time 2, but it's parsed out by year or partial year. If you have in your from and to dates that you're interested in just partial part of a calendar year, it'll parse it out that way for you. And then there's also a seasonal search as well, where it's just a selected season from time 1 to time 2 across multiple years. And I'm just going to do a seasonal search just to show you how this works. So I'm going to choose from May 1st, and I'll go through July 31st, 2006, and I'll do a seasonal search. In step 2, this is where you will choose the area to summarize by. You have two options. You can choose by state or by GAC, which is Geographic Area Coordination Center. But I'm going to choose by state. So I'll choose, again, I'll choose Arizona, California, and New Mexico, and I'm adding these to my selected states dialog box. And then you also need to choose which summary tables you'd like to produce. Do you want to just see the burn severity, the default selection, which is just the burn severity, or you can look at it stratified by life form and also by administrative ownership. So I'm going to turn both of those on as well. You review your query logic here in step 3 and then display the results. And initially what you'll get this tabular view where you have 3 tabs here. The first is the burn severity, just the burn severity for that particular season. You can see here that it's stratified by state and then burn severity class and associated acres. These columns are adjustable and sortable. So here's New Mexico. You can also do this by life form, which is your second tab here. So you can see you have your various life forms, high severity in Arizona. And then also by ownership. Again, these are all sortable. So if I'm only interested, say, in BIA lands, and I want to look at the severity by acres, I can do that. What's also kind of nifty is that we have this graphical interface as well. So you choose to view the graph. And you can display it by either by state or by season. So if I want to look at the season of 2005, for example, for Arizona, actually let's go to 2002, that's Rodeo Chedeschi. So I would choose my seasonal graph 2002, and then you can click on these highlighted bars and it'll show you a pie graph where it breaks out the ownership for that over here. You can punch out these pie pieces. If you hover on them, it'll give you the percent of high severity in that particular ownership with the associated acreage. Let's look at the moderate. Again, these are sortable. You can resize these. If we look at life form, and we want to graph that. Let's look at California. Here is our season for 2005, moderate severity. You can see the greatest percentage was in the shrubland. So it's just some cool analysis tools that you can do here on the fly. You can download the tables too by clicking this download button in CSV format. One thing to note here is that on the y-axis you'll note that the scale of the acres changes as you move from graph to graph. So here we have 120,000 max, and in 2002 it moves up to 180. So sometimes that's not entirely intuitive to people, so it can be problematic. So that is my demo. So I guess I will turn it over to back to Josh so that we can start the Q&A.
Okay, thanks, Jennifer.
Mm-hmm.
Okay, so I'll go ahead and dive right into the questions. There's a few questions have come in. Go ahead and type them in, and we'll get to them in a second. We'll start off with a couple here. And the first one is from Ralph Godfrey. And Ralph asks, how do you at EROS calculate the breakpoints for the severity map? Is it regression analysis?
At EROS, we don't do regression analysis specifically, and it's been done. We have done regression analysis by comparing on-the-ground control plots with satellite reflectance data, the DMBR and MBR values, but we don't do that for every fire. That was done initially to get some basic breakpoints. We definitely don't do that for every fire.
Okay. And the next question comes from Mark Vaughn. What are the NIR and SWIR wavelengths used?
So off the top of my head, I have to admit that right now I'm not. I admit I don't have that memorized. It's let's see, Jennifer, do you know what they are off the top of your head, or can you Google it really quickly? I can't remember exactly what the wavelengths are.
Yeah.
All right, it's just something I have memorized off the top of my head right now. The specific Landsat bands we use are bands 7 and 5.
So we have, for Landsat 5, band 4 is the near-infrared, which runs from 0.76 to 0.9 micrometers, and then band 7 is the short-wave infrared, which is 2.8 to 2.35. I don't know if you guys are still seeing my screen or not, but I have it up here.
Yeah, your screen's still up.
Okay. And that is 30-meter resolution, spatial resolution data.
Okay. All right, so the next question comes from Bruce Jackson, and he asks, what is the procedure when we identify fires missing from the MTBS database?
What you can do, if they meet the size criteria and you're able to provide us some location information, just go to that Contact Us page and go to the MTBS general mailbox, mtbs@fs.fed.us, and send us the information on that fire, and we can do a quick assessment to see if A, it meets the criteria, and if it has, and it was a fire that we've attempted to map already, and there was some reason that we couldn't map it, say it was a low severity burn, or it was under the canopy, or there wasn't any cloud-free imagery available to us to map it, we can do that assessment and answer that for you. And if it does meet the criteria and there is some good imagery available, we will certainly map it for you and get it into the data set.
Okay. All right, and the next question, another question from Ralph Godfrey. How do you want CBI truth breakpoint corrections submitted?
At this time, if he wants to submit it, he can submit it directly to me, or yeah, that's right now we've been creating databases of the CBI data, and so if someone collects CBI data and wants it submitted, we're eventually going to create a CBI database for different regions of the country, and that'll get posted eventually on the website. Right now we have data from the west and southeast, and a little bit, I don't think much in the northeast, but yeah, right now I'm kind of keeping the data, and then eventually Brad Quayle at RSAC will probably post it up.
Okay. Next question is from Robert Zeal. Is it possible to get a listing of fires that includes the date of fire?
Yes, if for fires that are mapped, I assume he's talking about. Yes, if you go out to the National Geospatial Data Portal, and if you download the fire occurrence data set, it will have an ignition date associated with each of the fires that we've mapped. I think that's what he's asking.
Okay. Okay. Robert, let us know if that's not what you're asking. Just type it in and I'll try to clarify. Next question comes from Mark Vaughn. Has this process been adapted to utilize aerial imagery, i.e. NAIP?
We don't really use NAIP imagery that much. We use NAIP imagery to examine, NAIP imagery has much higher resolution, and so we sometimes use NAIP imagery to zoom in and make sure that an area did burn, or not necessarily burn, but make sure we know what kind of landscape type is and what we're actually looking at. But as far as utilizing NAIP imagery to do this, we don't do that.
Okay. Here, I'm going to put up Yep, sorry. I was going to try to put up the website for where the recording is going to be. Okay. That's all the questions that we have. So I want to thank Josh and Jennifer for putting together a very interesting presentation, and also for all the behind-the-scenes last-minute arranging to get Josh into the webinar and to get his presentation up there. It was a pretty impressive bit of cooperation going on there. And I want to thank everybody for coming. If you would like to pass the link to this webinar on to someone, that it will be posted here in probably an hour or so on the Advances in Fire Practice website. That's the link that's on the first top link there under Advances in Fire Practice, and you can grab that and send it off to whoever you like. And with that, I just want to thank both the speakers, Josh and Jennifer, for coming. And next week there will be the follow-up to this webinar. Eric Adula was showing how Grand Canyon National Park has been using the information produced by this project. All right, thanks, guys.
Thank you, Josh.
Yep, thank you, Josh.
All right, thanks, everybody.